Hi everyone, my name is Doug Duncan, and today I'm going to walk you through a Python program I designed that simulates a very dramatic game, Global Thermonuclear War. Don't worry, we're not actually launching anything. This is all for fun and learning, and to show how basic Python concepts can power something that feels like a movie computer system. I'm going to explain this as if you've never seen Python before. So if some of this looks like another language, well, that's because it is. But by the end, you'll see how everything fits together. Before we dive into the code, here's what the program actually does from a user perspective. It pretends to boot up a military computer called WOPR. It asks you to log in with a username and password. Then it drops you into a command prompt where you can type commands like list games or play global thermonuclear war. The program then walks you through whether you want to play, how many missiles you want to launch, which city you want to target, a dramatic DEFCON countdown, and finally an outcome that reminds us nobody really wins a nuclear war. At the end, the program saves a log file of everything that happened. Under the hood, this program uses variables to remember information, functions to group tasks into reusable pieces, booleans for true or false decisions, loops for repeating actions, input for collecting what the user types, conditionals like if and else for branching paths, and file writing to save logs. Alright, let's crack open the code. First, we've got the imports. These are like inviting specialists into the room. Time is here so we can pause the program for dramatic effect. Sys lets us control how text prints to the screen, letter by letter, very 1980s terminal. Datetime gives us timestamps so we can log when things happen, because if it's a military system, you know somebody wants logs. Next up, we set some global variables, basically top-level memory the whole program can use. Command log keeps track of every command the user types at the WOPR prompt. Event log records major events, things like booting, entering DEFCON levels, starting the simulation. Last scenario summary will store the last WarGame results so we can replay it later. Current username starts out as user and updates when someone logs in. Think of these as the WOPR's long-term memory for this session. Now let's look at the first utility function. Type slow. This is the function that gives us the movie computer effect, printing one character at a time. This gives the screen an eerie effect. Instead of every character getting presented at once, we get one character at a time. For example, instead of Doritos, we get Doritos, Doritos. This sequence gives the scene its flavor. Next, we have log event. This one takes a message, attaches a timestamp, and adds it to event log. Anytime something important happens, boot completes, the user starts a simulation, DEFCON changes, we call log event, and it quietly records everything. Think of this as the black box recorder for our WOPR simulation. Now for the fun part, the boot sequence. Inside this function, we have a list of lines that describe what the system is doing. Loading firmware, performing memory checks, initializing the thermonuclear simulation kernel, mounting NORAD partitions, linking to strategic air command. And my favorite, warning, simulation contains irreversible outcomes. We loop over these lines, print them slowly using type slow, and sprinkle in little pauses with time, sleep. At the very end, we print system ready. Welcome, Professor Falcon. So right from the beginning, the user feels like they've dialed into something they shouldn't have access to. We also log this event, so the system remembers it actually booted correctly. Once the WOPR has booted, we run login sequence. We ask for a username and a password. And yes, any password works. This is the least secure system since password 123. If the user doesn't type a username at all, we default to user. Then we simulate a dramatic access check. We log the user, so now the system knows who is about to cause all this trouble. Now we get into the command shell, the part that feels like hands-on hacking. The program explains what kind of commands you can type at the WOPR prompt. List games, play global thermonuclear war. Help! Exit. We store each command the user types in command log. So if someone types list games, or list games, we normalize it to uppercase and record it. Show help menu just prints a friendly list of what they can do, perfect for classmates who are brand new to command line style interaction. List games and the no boring choices twist. If the user types anything that looks like list games, we show a list of games, just like in WarGames. After that, no matter what boring game they want, the program nudges them toward global thermonuclear war anyway. So the computer basically says, "Oh, you wanted checkers? That's adorable, we're doing worldwide annihilation." This keeps the story moving and keeps the movie reference strong. Other commands. If the user types exit, we log that they left without starting the simulation. If they type nonsense, we show an error and suggest help. Eventually, either directly or indirectly, we end up starting the simulation. Now let's look at some helper functions that make user input safe and beginner friendly. This wraps the classic "do you want to play a game?" question and keeps asking until the user gives a real yes or no. Now it is time to select the missile count. Note, only 1, 2, or 3 are accepted. Anything else gets a friendly scolding. We print a numbered list, explain clearly that they must type 1, 2, 3, or 4 and press enter, and keep looping until they choose a valid option. All of this is very new user-friendly, which is perfect for a classroom demo. Now we escalate things. We start at DEFCON 5, then drop down to 1 with 1-second pauses between levels. Then we count down from T10 to T0. This is where you can really ham up the sound design. Add beeps, sirens, maybe a low rumble while the numbers tick down. Now we tie it all together in playground function. If the user says no, we do a fun callback. If they do want to play, we ask how many missiles they want to launch. Then we give a custom, slightly sarcastic response. 1 missile, tactical strike, might chip the paint. 2 missiles, definitely a bad day for someone. 3 missiles. Okay, relax there, General Apocalypse. Then we ask for a target city. We run the DEFCON escalation and countdown function, and then we decide the outcome based on the selected target. Finally, we print a summary, and we store it in last scenario summary so we can replay it later. Then, one last ominous line. Thank you for playing. The simulation is now over. Or did it just begin? Because if you're going to simulate nuclear war, you might as well end spooky. We also have a simple function to replay the last scenario. And then there's the logging system. We assemble the username, session time, command log, event log, last scenario summary. We write all of that to a per session file and then append it to a master log file. This is huge for teaching. It shows how to open files, how to write text, how to append to a log across many runs. And it also feels like official declassified documents of your little world-ending adventure. At the end of each simulation, we show a menu. Option 1 runs another simulation. Option 2 replays the last summary. Option 3 exits. Back in main function, we glue everything together. So the flow is boot the WOPR. Log in. Enter the command shell. Run 1 or more simulations. Let the user review or replay. Save everything to log files. Exit cleanly. So that's the full breakdown of my global thermonuclear war simulator in Python. We didn't use any advanced libraries or complex frameworks, just functions, variables, loops, conditionals, user input, and a little bit of file I/O. But by layering those basics with timing, sound, and presentation, we turned it into something that feels like you just hijacked a Cold War supercomputer. If you're new to Python, I hope this shows you that you don't have to wait until you're an expert to build something fun, thematic, and interactive. Thank you for watching. And remember, the only winning move is not to play. Unless it's Python, then by all means, play.